Great, ladies and gentlemen. So we are recording and we shall overcome. So this is advanced management accounting, and specifically I'm reviewing what we did in our last class, and I'm going to look at regression analysis, and I would want in this lesson to do only one question. Yeah, regression analysis. That is topic number 2. Topic number 2. Yeah. And I would want to do one question out of the 3. And then, of course, I'll be able to provide answers later. Answers later for the other questions. For the other questions, we shall provide answers later. Answers later. So, and I will choose to do the very easiest in class. The one that I know that everybody got right, which is August 2024, question number 2, boy. August 2024, question number 2, boy. August 2024, question number 2, boy. And this class is going to be the most interesting class. So long as ulikula lunch. Kama ukula lunch, haitakuwa mzuri sana. Yeah. So do you have the question paper? We shall always start, ladies and gentlemen, reading our advanced management accounting questions from the requirement. So you go to the requirement. For you to be able to understand the question very well, always start by reading the requirement. So the requirement, they want me to write down the linear regression equation model. That's number 1. Number 2, we find the missing values of XA, XB, XD, XE. Whenever I see the concept of missing values, I know this examiner is that examiner who is wishing me success. Explain the statistical meaning of the standard error of estimate. Errors are variations. The bigger the errors, the poorer the model is for prediction. That I can even answer without reading anywhere, because standard error measures the discrepancy of these expected values from the mean. The bigger that error is, the bigger that discrepancy is, the poorer the model is for prediction. Do we know what R squared is? We're reading this question on September. It is September what? It is September. It's August, August 2024, question number 2B. Thank you so much. So do you remember the concept of R squared if you're asked here? Before we even read the question, there are things as I read the requirements I should be able to understand. What is R squared? We discussed. No, don't make reference to the notes. It is already in your mind, in your own language. If you're a Kikuyu, speak to me in Kikuyu. If you're coming from whichever area, speak to me in your own mother tongue. What is R squared? Do you remember the concept of explained variance proportion? They must have forgotten that R squared is the explained variance proportion. The bigger the R squared is, the better the prediction abilities of the model. I'll be able to give you answers, but I would want you to understand. Then they also want us to explain what F ratio is, which I shall be able to do immediately. How about Roman 4? Using the economic plausibility tests, is the regression model significant as a predictor model? What is this economic plausibility? We also touched it in our last class. Economic plausibility, ladies and gentlemen, basically when I'm looking at it, I will be asking myself whether the model, the equation that we have at hand, does it make sense? So if, for example, you are given here y equals, say, 10 plus 5x, and then they tell you that y is sales, all right? And then they tell you that x is what here? Advertising cost. So first of all, even before you look at the model, what do you expect to exist between sales and advertising cost? I expect a positive relationship. The more I advertise, the more the sales should be, isn't it? One-on-one positivity. So this is the kind of relationship that I expect. If I was to do a diagram here, I would expect in this case here, this to be sales, and in this case here, this to be advertisement. So when we increase our advertising amount, we expect sales to grow. So we expect a positive relationship. Is the gradient positive here? Do you remember? Do you remember we discussed this and said if you're given like y equals a plus bx, this is called gray? And I can see my gradient here, which is 5, it's positive 5. So then this means that the model is economically what you apply? Plausible. It is making sense. If, for example, here they had a negative, that would have meant what? If it's a negative relationship, that in this case here, the more we advertise, the sales in this case here reduce, that doesn't make sense. And if it doesn't make sense, we call it a nonsense model. But we give it a special name, spurious. We said if it's a nonsense model, let me test you on this. Assuming we have here demand equals 20 minus 10 price. This model, is it economically plausible or is it spurious? You know, there is somebody who will think that anytime they see a negative, they'll be writing spurious. I haven't taught you about that. Is it plausible? Does it make sense, this model, the way it is, or it doesn't make sense? Let me see. Let me see what these ninjas are saying online. Let me see what they're saying online. Is it plausible or spurious? Why plausible? Yeah, because demand and the price are negatively related. Demand and the price, we expect in this case here, the quantity demanded versus the price that is charged to have a negative relationship. If you remember very well from your economics, this is the kind of model we expect. We expect our line in this case here to have a negative slope. Why? Because if this is, doesn't matter, price versus say quantity demanded. You can see, ladies and gentlemen, when in this case here, the price is at the very lowest here. When the price is at the very lowest, demand is very high. And when price in this case is at the very highest, demand is almost what is it? 0. So here we expected a negative slope and therefore a negative boy, negative B. So when I come and I see this one is there, so it is economically what you apply? Plausible, yes. That is how you interpret this concept of plausibility. This concept of plausibility. But now let's read the question itself. Let's get to read the question itself. So what are we told up here? What are we told up here? So what you're told up here is Plasma Electronics Limited supplies digital decoders and liquid electronic display LED television sets for high-end users. Our great customers contract Plasma Electronics Limited with requests for maintenance of their terrestrial signal frequency. To estimate the service cost, Plasma Electronics Limited wishes to predict the installation time. They want to predict the installation time. So the installation time is their Y. They want to be predicted always goes to Y. In hours, which is a dependent variable is the Y variable necessary for each maintenance request. Installation time is believed to be related to 2 factors. Number 1, the number of months since the last maintenance services, and then the type of maintenance problem, whether digital or what is somebody analog. The following is a summary table for time versus months and the time. So you can see the predictor, constant, months, the type there. We can see their coefficients. We can see their standard errors of coefficients, and then we can see the T ratios. Then, ladies and gentlemen, we are able to see the standard error. It's given here. We have our R squared, which is very high. About 86%, very high. Very good. And then we have R squared adjusted, which is 82%. Then they have given us analysis of variances ANOVA. So ANOVA, we said variances, there are 2 types. We have what we call the explained and what is somebody? Unexplained, yes. So then they want us to write down the linear regression equation. I will not do that question first because one of the coefficients is missing. You can see this coefficient here, X is missing, right? So then the very best thing to do is to do part 2 first. We do number 2 first, where they want us to find the missing values of the XA, XB, XD, and X what here, somebody? XE. So long as you do your numbering very well, there is no problem. Let's do the second part. So you write that question, and then you mention there that you are doing Roman 2, missing parts. So we are doing Roman 2. First of all, we get these missing parts for us to be able to go back and pick our coefficients to be able now to write down the equation. Write down the equation. Please, if you have a question, and sure you are asking, online guys can always ask on the chats. The guys that are with here can always raise their hand, and then we get, in this case here, to answer them. Great, Njeru. Thank you so much. So now we are looking for the missing sections, the missing numbers. And these missing numbers, I can see them all over. For example, I can see XA. Let's start with XA. XA. So those guys who say they're done their homework, who would want me to give them money now, I'm here to see what they got for their XA before I continue. Do you have an XA answer? XA equals XA. Online guys, I can't hear them. XA equals 2.5? 3.5? The online ninjas, I can't see them, and yet they're claiming that they did their homework. These online ninjas, I can't see them. I can see Mercy. I can see, in this case here, Hilda. I can see Joseph. Yeah, about 9 of them should be able to get my money today. Now, for the sake of the students who are joining us for the very first time, this is not a hard nut to crack. No. Because I can see XA is under the T ratio. So the most important thing is for me to understand and cram the T ratio formula. Understand and cram the T ratio formula. Is there somebody who is able to remind us how we normally get the T ratio? Thank you so much. So they want us to give them XA. And they're telling me that this XA is the T ratio, which they have been able to tell me is coefficient over what here, somebody? Standard error of the coefficient. Isn't it? Yeah. Yeah. So remember, XA is T ratio here. So I'll come and write XA equals. So where you are able to see XA, are you able to see the corresponding coefficient? Where we are able to see XA, XA is here. And I can see this is for constant. So I can see the coefficient here, 0.93050. 0.93050. Divide this by the standard error of the same coefficient, where you can see XA. You are able to see the standard error of the coefficient here as 0.36 what here, somebody? 70. 0.3670. So I hope in this case here, all of them are then able to get the same T ratio here, which is 2. What here, somebody? 5354, isn't it? That is XA. That is XA. So even if you are a very, very new student, it's all about, in this case here, cramming this formula of T ratio. T ratio. Don't even try to ask yourself so many questions like, what animal is this T ratio? So just cram the formula, use that crammed formula to pass your exam. Once you pass your exam, the end in this case here justifies the mean. So long as the end is nice, how you went to the very end, we will not want to know. So that is XA. That is XA. And then now we can go to the second missing metric. The second missing metric, ladies and gentlemen. The second missing metric, oh yeah. It is XB, isn't it? XB. And still we're going to use the T ratio, isn't it? Yeah. So we're going to use the T ratio formula. Now we are getting XB. Now we are getting XB. My friends, in this row where you are seeing XB, you can see the T ratio is 6.2. And then this is the standard error missing. And then the coefficient is 38,762. So mine is simply to write down this formula and then show the examiner that now I'm getting X boy, isn't it? Now we are getting X boy. And the T ratio will be equal to the coefficient over the standard error On that row where you are seeing the boy, are you able to read for us the T ratio? Please read for me. 6.2 equals coefficient. Do you know the coefficient? Coefficient is 76, 0.38, 762, isn't it? All over the standard error that we do not know, which is called what, yes, somebody? XB. So then can you kindly go ahead and make XB the sub? Had you done your homework? We shall overcome. Don't worry. We shall overcome. This is an adult class. We call it Gubaro. Wezi uchapa mwanafunzi. Wezi kusana mwanafunzi. So long as you are trying. So long as you are trying. We are trying. So make XB the subject. So it will be 6.2 XB equals 0.38, 762, isn't it? Yeah. And then get ahead and make, I've just cross multiplied. I've just cross multiplied. Then XB will be 0.38762 divided by 6.2, which will end up giving me what figure? Thank you so much. Thank you so much, Quinta Atieno. 0.0625, isn't it? Thank you so much. Whatever you're getting is really resonating well with my physical students over here. Yeah, thank you so much. Billy Kaku, my friend. Billy Kaku, my friend. We are meeting in this case here in the advanced level now. The advanced level now. Some of you have seen you from the intermediate level, others from foundation level, other ninjas here have been with them from ATD. ATD. All right, now we go to the next one. The next one is X what? XC. So XC, where is this XC? Very easy. I can see XC is here. Eh? Yeah, XC is here. So XC is there. So now we are getting XC. So you can see the row where XC is in. You can see it is in row number 3. I can see coefficient is the one that is missing, right? SE coefficient, already we have it. And the T ratio, we have it as 4.02. So now I'm getting XC. Unfortunately, I'm using the T ratio approach. So long as I know that I'm using the T ratio approach, then getting these numbers becomes as easy as a walk in an animal park. Yeah, in an animal park, the walk over there is very, very easy. So then please give me the numbers here. Where XC is in that row, are you able to see the T ratio? What is the T ratio here? 4.02. Do you know the coefficient there? It is X, isn't it? But fortunately, we know the standard error of coefficient, which is 0.3141, like that. And therefore, make X the subject of the formula. It will be 4.02 times 0.3141. 1.2627. Thank you so much. 2627. Thank you so much. So already we have up to XC. It doesn't stop there. There are still other missing metrics in the next table, right? In the next table. So far, I'm not seeing anybody asking questions. Please, should I forget to see the chat area? Always remind me. Always remind me. And how comes, ngoja kidogo kwanza niwaulize swali. Wanafunzi wa online, unasema hatuko tumefix class Saturday 6 p.m. and I can see you are 120 online. So, mlijuaje kuna class nyinyi? Hao wanafunzi 120, mlijuaje kuna class? Nyinyi ndio mnakataa. We're going to fix class on Wednesday, Saturday 6 p.m., Sunday 6 p.m. And if you're in Nairobi, you should always come around here and join me, isn't it? In class. So even tomorrow, I'll be around. Hao wanafunzi wa online walikuwa shaniambia mzee rudi nyumbani. Nikamwambia siwezi rudi nyumbani. Wacha nifunze, nimeshakuja town jameni. Uzuri wakakubali. Ukasema mwalimu tusome. Very good. Very good. We shall overcome. shall overcome. Why are we introducing these extra sessions much earlier? It's because of how this subject is structured. It's quite an intense, very interesting but intense subject, which needs you and I to put effort doing our class homeworks, doing class exercises. We have to do a lot for us to experience what we call one term. Ladies and gentlemen, if you're not aware, and I told you this in the last class, in 2027, we are changing the syllabus. We don't want anybody to be an opening stock in a new syllabus. In a new syllabus, if you are an opening stock, you shall lose quite a lot. So in this 2026, we have got quite a lot to do. We must finish all the papers in 2026. And because of that, the new guys must fold up your sleeves and work hard. There is no choice. No choice. Just vile nilikuwa namwambia last semester, mimi nitangoja msome hata nitawasomea. Ndio muweze kufanya mdangani kupi, even if it means me reading for you. Hakuna option. Lazima mpite. Lazima mpite. So next year, it's a new syllabus. We don't want this new syllabus to catch us. No. So then we continue. Now we go to XD. I love XD so much. XD is under something very great. Are you able to see XD is under mean sum of squares? So XD, I'll use this XD is under M. It's supposed to be MSS. Your examiner at times becomes lazy and they call it MS alone. It is MSS. MSS is mean what here, somebody? Sum of squares. Mean sum of squares. Is there anybody who is able to remember the formula of MSS? Yeah, it is SS over degrees of freedom, you're right. Just to give them the mean sum of squares, we shall always take the sum of squares divided by degrees of freedom. So in short, is what you have heard students telling me, that mwalimu MSS is SS over DF, like that. Great. So now where you are able to see XD, on that very row, where you are able to see XD, on this row, where we are able to see XD, on this row, this is what I'll use, XD. So I can see XD here is the MS, right? So I want to substitute. I can see sum of squares is 9.0009 divided by 2. So XD. So now I'm plugging in. So MSS, this is my XD, equals SS. SS is 9.00 what here? 9. All over degrees of freedom, which are how many? 2. So then you go ahead and divide. So what are we able to get, ladies and gentlemen, here? 4.50045. Thank you so much. That is XD. Do we have XE or that is it? We have XE, yeah? XE. XE already, Harriet has gotten it. Harriet has already gotten XE as 1.4749. Yes. Okay. So a student is asking a very, very good question here. When getting, in this case here, this XD, is it possible for us to use the F ratio? That's a very interesting question. I love that question. If I had money, sister, today, I would have given you 2,000 bob, right? That's a very serious question, yes. Very, very serious question. So let's, in this case here, try getting this XD using the F what here, somebody? F ratio. So this F ratio, are you able to remember the formula first of all? F ratio equals explained MSS over, even you, if you had money, I would have given you something. So F ratio is explained what here, somebody? MSS over unexplained MSS, like that. So then the very first thing, remember, okay, the very first thing that we need to do is to come and compute this F ratio itself. Let's compute F ratio. We assume that the F ratio given there, we assume that the F ratio given there it doesn't exist. We assume it doesn't exist. And then we look for it. We look for it. These are very, very good questions she has asked. Very good questions she has asked. But first of all, I want us to remind ourselves, for the sake of the very new students, so that they don't get confused, that regression, or rather, yeah, just talk over an ANOVA. ANOVA stands for what here? Analysis of what here? Variances. So under ANOVA, we have two types of variances. Under that ANOVA written there, ANOVA, we have two types of, you must write this even if you wrote it in the last class, because you must always assume that you know nothing until you pass your exams. For now, you know nothing. So we have how many types of variances? Types of variances. Do you remember them? So number one, full colon, explained. And this explained variance is what we call regression. At times you'll get just the examiner using the word model variance. Whenever you hear model variance, know that that is the variance that has already been explained. Model variance. And then on number two, we have what we call unexplained variance. Do we have any other names for unexplained? Yeah, it's error variance. It is error variance. It is residual variance. Bad names they use for them. Residual variance. So anytime you see your variances, they'll always be given in those two categories. They shall always be given in these two categories. They shall always be given in these two categories. So like in this question, have they given us those two variances? Let's see. Have they given us these two variances? If you see here, ladies and gentlemen, you can see the attempts, they call them type of variance or source of variance. So you can see we have regression versus what here, somebody? Regression versus residual error, isn't it? Yeah, regression versus residual error. Regression versus residual error. Regression versus residual error. So now the variances have been given to me. The variances have been given to me. The variances have been given to me. So now we have our variances in form of mean sum squares. So we have regression, what we have just called what here, explained. So are you able to see that amount? We got it, isn't it? MSS, we got XD. It was what figure, somebody here? 4.500. Oh, 4.05 like that. Yeah. And then now we have in this case the residual, what we are also calling what here, unexplained. And our unexplained figure, in this particular case, you can see unexplained, the residual error. You can see it is 0.21, 0.2107. Thank you so much. Thank you so much. Thank you so much. Now, given these two that have been very well explained, is there someone who can give me the F ratio there? Let's see. Because already I've given you the formula and I've taken my time to really explain, for you to understand what explained variances are and what unexplained variances are. 21? Are you reading the one that is in the question? Or you've computed there? So if it is known, is that to get F ratio, we take explained mean sum of squares, which is 4.5005 all over 0.21, what here, somebody? 07. Yeah, explained MSS of unexplained MSS, isn't it? So if you divide the two, what figure are we able to get from the online ninjas? I can see a figure here, 21 point something, isn't it? 21.36. So is this the answer given there in the booklet? It could be very close, yeah, times not exact, but very, very close. So now the student is asking, can we use this F ratio here to get, in this case here, some parameters? Yeah. And I'll be able to show you from your old past papers. When at times you go and realize that an examiner has, I should not have rubbed this, but it can overcome. So the examiner comes and tells you that the F ratio, in this case, is 21 point what here, for example, 36. He gives you that. And then he can go ahead and give you MSS. Yeah, he can go ahead and give you MSS, explained MSS. Let me just write here, explained MSS, like 4.500 what here, somebody? 5 like that. And then, of course, in this case here, he doesn't now give you an explain, he misses this. So if he doesn't give you that, then you can play around with your numbers to get what here unexplained. And then, of course, you can as well work backwards. So you'll see these examiners at times, they are very, very bright. So what they will do, they'll come and give you unexplained degrees of freedom, for example, what here? M. And then they mean giving you what here, somebody, some MS. So you can easily work backwards until you get whatever. So long as you're so good in these formulas, you can never ever go wrong. So the very best thing is for you to be just conversant with these formulas. Once you have them, then you can work backwards to whatever this examiner has given you. Yeah, whichever short road that gets you to Afghanistan, take it. I love that. But why would I want to go to Afghanistan? So if it's Afghanistan, which is a war area, I would want in this case here to take the longest route. If it's a must, I go there, isn't it? If it's a must, I go there. But I hope I've answered your question. With this, you can easily be asked anything. You can easily walk back and what you get whatever they ask you to do. Singapore, yes, Singapore would want to be there tomorrow, isn't it? Singapore, shortest, yes. That one want to be there tomorrow. But do you think we shall ever reach there as a country? Why not? Let's be very positive. Let's be very positive. Work and work and work. So now let's get XE. XE, already you have an answer for XE. So we want to get XE. So XE, which formula do you think shall we use to get XE? When I look at XE, it is still under this concept of what here, MSA? Yeah, it is under the table of M, it's under ANOVA. So ANOVA parameters, we use the MSS formula to get. Yeah, so then I'll be able to come and write here, MSS equals SS over degrees of what? Freedom. So if I clear my screen very well, this row where we have XE, 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 I can see here. I can see the degrees of freedom column has 7. Is that okay? I can see sum of squares we've got what there? XE. Means sum of squares, what we have there, somebody? 0.2107. So it's about plugging in. Yeah, I hope the new brother is able to get the question. Take care of the new brother. So MSS Chigana, 0 point. 1? No, I want MSSS. 2.2107. SS ndio hatuna. Hiyo ndio X, isn't it? But degrees of freedom, we have this as 7. So cross multiply. So when you cross multiply, we shall be able to get XE as 7 times 0.2107, which will end up giving us 1.4749. So what I'm 100% assured of, especially for the students who never did their homework, they're celebrating that if I did my homework, I would have gotten everything, isn't it? It was very easy, right? You would have gotten 0. That's why you never did the homework. Ah, yes. So in this case here, going to Singapore, the easiest way, somebody called Pius here is saying, you already have the total. Just do what you subtract. And I can as well see another ninja here also sharing in the same school of thought. There are many ways of killing a rat, ladies and gentlemen. You can decide to use rat and rat poison, or even burn the whole house to kill all of them, isn't it? So now, is there anybody after getting those missing parts? Is there anybody who is able to answer number one? Give us an answer to question number one. I doubt. Question number one, they want us to write down the linear regression equation. Yes. So please write it down. These guys have done it. I know I'm wasting your time, but we shall overcome. Let's just move a bit slow. We shall overcome. We shall overcome. We shall overcome. We shall overcome. So if it is regression equation, I know I'm going to use the coefficients. These ones here, isn't it? Yeah, the coefficients. So these are the two predictor variables. So my y will be a plus b1 x1 plus b2 what here somebody? X2. So remember that a is the constant coefficient. A is the constant coefficient. This one here. Constant coefficient. 0.93, 0.50, isn't it? Plus b1, the coefficient of x1. Coefficient of x1 is 0.38, 762. 0.38, 762 x1 plus, you know, there is this coefficient xc which you guys had gotten. You already have it. 1.2627 x2, isn't it? Already you have everything there. So if you wish, you can substitute here. This is in installation. If you wish, up to there you are okay. But if you wish, just to demonstrate broad understanding of the subject, installation time will be equal to 0.93050 plus 0.38, 762. Yeah. X1 stands for number of months, isn't it? Number of months. It's written there. Plus 1.2627 type. Yeah, type. Oh, I'm wrong, 1.2? Where? Yeah. You see, it is XC. Is it XC or something? And we had, if you look at your where you have written, we had looked for that unknown XC. Yeah, you'll need to see that 1 point something. Just check again. Okay. All right. Thank you so much. What are the online ninjas saying? What are the online ninjas saying? Please feel free to ask questions. Yeah, Lindo Bura, very, very good. So before I wrap this question, this working, could you kindly tell me whether this model is economically plausible? And why do you support economic plausibility? Yeah, you said say yes. Why do you support economic plausibility? Months, gradient is positive, all right? So can you kindly then prove that months and the installation time is supposed to really have a positive gradient? How do you prove? Tell me. Since there is a positive correlation. No, then you guys have not understood how you're supposed to be answering this question. Because I agree with you, it's economically plausible. So we start with the first variable. These months and installation time, are they supposed to be positively related or negatively related? Positively. Yeah, so the more the months, the more the installation time. So it's months for what? These are months for what? For repair. Read. read kidogo tuone. Baadaye nasema hapo kuna shida kidogo. Hii ni months for what here? Try to understand these months. Months for doing what? Let's see. Yeah, let's see these months are months for what? You can see installation time is believed to be related to two factors. The number of months since the last maintenance services. Number of months since the last maintenance services. So kama ulikuwa maintain this system kitambo sana, kama leo tumekuwa tukiweka billboard zetu hapa nje. So kama ulikuwa maintain kitambo sana, kama chapa ukiweka chini to install it back, you expect the installation time to be what here? Be more. Because last maintenance time kama ilikuwa ni kitambo, so it means that even that particular gadget is what is old, isn't it? Now in this case installation ni vitu mzee, hapa inaguza, hapa inaanguka, ingine chini, namna hiyo. So then we expect, ladies and gentlemen, months in this case here, and the installation time here to be positive relay, and you can see that the gradient is what here, somebody? The gradient is positive, yes. If it was the opposite, I would have said automatically that that model is what is spurious. Because these months are too many since we did maintain. For example, last time we did the maintenance, ladies and gentlemen, in this case here is, for example, 5 years. Hata gari kama ulifanya maintenance kitambo sana, ukitaka kuinstall vitu mpya itachokeza sana, vitu mingi itakuwa imeharibika sana. How about this type, ladies and gentlemen? What relationship do we, first of all, what is this type? The maintenance problem, isn't it? Yeah. So this maintenance problem, if it's big, installation time will be big as well. So the type of the maintenance problem, is it digital? Is it manual? The type of the maintenance problem. So if this type of maintenance problem is big, ladies and gentlemen, then we expect installation time to also be big, to be a lot. So then we expect in this case here a positive water relationship, and for sure this is a positive gradient. So don't worry about that. We shall be able to answer. I just wanted to bring that to your attention. Somebody is asking me to start AI. I don't know why. Start AI companion. That works very well for leadership and management. I doubt whether it can work well for advanced management accounting. Nevertheless, always give way. In life, you should always give way. Give way. All right, then, ladies and gentlemen. So please expect me to go to the next thing, because that one we shall be looking at it. So Roman 2, find, yes. Or 10 minutes break, we pray. That is very, very important. I will also pray. Everybody to pray. So we shall come back at exactly 7:00. 7:00. All of us shall come back at exactly 7:00. Yeah, we haven't yet reached there. Okay. Somebody is saying, Mwalimu, you are going too fast. We shall overcome. The question is, remember, I'm doing a homework, a question that most students have been able to do. You can even see they're responding. They're giving me answers. Where were you? How comes you never did your homework? Because you would want me to take a whole 2 hours to revise. You must do all your homeworks. We shall overcome. Does CASNEP give exemptions in the advanced level? No. No. All right. Now, ladies and gentlemen, here we are. So we have been able to get XA to XE. We've been able to write down the regression equation. Now they want us, ladies and gentlemen, what do they want us to do next there? Roman 3. In Roman 3, what do they want us to do next? So in Roman 3, they want us to explain the statistical meaning of the standard error of what here? Estimate, R squared, and the F statistics ratio. So we start with the standard error of estimate right there. Standard error of estimate. Standard error of estimate, SE. Standard error of estimate. Just explanation. Just explanation. In your own language, in your own words, what would you say is the standard error? So right there, this measures the accuracy. This measures the accuracy of the regression model. Of the regression model. This measures the accuracy of the regression model and gives the indication of the absolute size of the probable deviations from the regression line. So I repeat the whole of it. This measures the accuracy of the regression model and gives the indication of the absolute size of the probable deviations from the regression line. The smaller the standard error, the more accurate the regression model is. It's an error. An error is a deviation. And if the error is big, then the model will become inaccurate in terms of what you predict, in terms of predictions. I can repeat. The smaller the standard error, the more accurate the regression model is. So up to there, are we together? Then they want us also to explain R squared. R squared. So right there, R squared. This explains the extent. This explains the extent to which the variation in the dependent variable, to which the variation in the dependent variable is explained, and caused by the variation, in the independent variables. I'll repeat. This explains R squared. This explains the extent to which the variation in the dependent variable is explained and caused by the variation in the independent variables. The higher the R squared, the more reliable the regression model is. The higher the R squared, the more reliable the regression model is. So we're saying there, I repeat, this explains the extent to which the variation in the dependent variable is explained and caused by the variation in the independent variables. The higher the R squared, the more reliable the regression model is. F statistic. Ladies and gentlemen, please listen and listen to me very well. We have what we call hypothesis tests in regression. I can actually write this as a note. That there are two types of hypothesis tests in regression analysis. Namely, number one, we have a hypothesis of coefficients. Hypothesis of coefficients. And then number two, we have a hypothesis of whole equation. So there are two types of hypothesis tests in regression analysis. We have a hypothesis of coefficients, and then we have a hypothesis of what here? Whole equation. Remember, hypothesis is also known as significance tests. Is also known as significance tests. So how significant are our coefficients? How significant is the whole equation? Ladies and gentlemen, hypothesis of coefficients, we use T statistics. We use T statistics there. And if you remember very well in our last class, we said the higher the T statistic, the more significant a coefficient is. The more significant, the higher. When it comes to hypothesis of the whole equation, we use F statistic or statistics. F statistics. You simply cram. There we use F statistic. Again, remember, ladies and gentlemen, the higher the T stroke F statistics are the significant. The coefficients stroke whole equation is or are. So the higher the merrier. So the higher the T, the higher the F statistics, the more reliable the whole equation will be, the more reliable the coefficients will be. I'll repeat. Hypothesis is also known as what is significance tests. And the higher those T and the F statistics are, the better, the more significant the coefficients or whole equation will be. Very, very important. So whenever they tell you to describe F statistic, you will remember, tell them that F statistic is used to test the significance of what here somebody? Whole equation. If it is T ratio or T statistic, it is used to test the significance of what here somebody? Coefficients. The moment you mention like that, you get all the marks. So I repeat, because I would want us to do what this examiner had told us to do. They wanted us, ladies and gentlemen, give them F statistic to describe what F statistic is. So write there F statistic. Write there F statistic. This tests the significance of the regression model. This tests the significance of the regression model significance of the regression model by comparing the mean sum of squares. By comparing the mean sum of squares, I repeat, this tests the significance of the regression model by comparing the mean sum of squares explained by regression. The mean sum of squares explained by regression and that not explained by the regression. This tests the significance of the regression model by comparing the mean sum of squares explained by regression and that not explained by the regression. If the test statistic if the test statistic into bracket F ratio is greater than the critical value, is greater than the critical value into bracket F table. I repeat, if the test statistic F ratio is greater than the critical value into bracket F table, the regression model is significant. The regression model is significant, and vice versa, full stop. That may look complex for nothing. That may look complex for nothing. Ladies and gentlemen, if I'm the one who is answering that question, this is how I will be able to answer a question regarding to a description of the F statistic. When they tell me in this case here to describe the F statistic. So first of all, I'll tell them that this is a significance test of what here, somebody? A whole regression model. A whole regression what here more? Model. The higher it is, the significant meaning more reliable. The significant, a model, the significant, a model is. And then I'll be able to go ahead and give them the formula for getting F ratio. Do you still remember this formula for getting F ratio? That's what they're trying to explain there with so many words. F ratio equals who? Explained MSS all over unexplained MSS. If you do it that way, you will end up getting all the marks. You don't have to keep on saying F critical, F table. No. So I hope up to there, ladies and gentlemen, we are together. Yes. Oh, p-value. Great. In one of the questions, we had a p-value for measuring what here? Errors. I'll be able to do that question. Thanks for that question. But I prefer we tackle that when we do that question. Is that okay? Yeah. The last part of definition of F statistics. Lazarus, or repeat. But I think this is a better one, if you don't mind. This is a significance test of the whole regression what here? Model. The higher it is, the significant, more reliable the model is. And then F ratio equals explained MSS all over unexplained MSS. And then if you want me to display the last part, so the last part, ladies and gentlemen, here, for the if the test statistic F ratio is greater than the critical value, so F table, then the regression model is significant and vice versa. Again, there is another question that I'll be doing where I'll be able to demonstrate this concept instead of explaining so many things, which will confuse you. So with your permission, ladies and gentlemen, allow me now to do the last part, where they want us to use economic plausibility test. Is the regression model significant as a predictor variable? Fortunately, we already have this model with us. Fortunately, we have this model with us. So fortunately, we have this model with us. So the model itself, our y was a plus b1x1 plus b2x2. So our y will be equal to a, which we already have, 0.93, 0.50 plus b1, which is 38, 0.38, 762 plus b2, this is x1. B2, I don't have the value for B2. It was 1.2627x2. And then don't forget that this was installation time equals 0.93050 plus 0.38762. X1 was what here? Somebody months, isn't it? Months plus 1.2627 IPS. Yeah, type. All right. And then now, ladies and gentlemen, remember to define your variables very well. Remember to define your variables very well. So the months, what do these months represent? So you told me something about months. Please go back and read. What do these months in this case here represent? Months, time for what? Time? No, I haven't gotten you very well. Yeah, so please read again. Months, number of months since the last maintenance service. Since the last maintenance service. All right. Then we go ahead and even explain this further. Let's have a note there. To understand this, let's have a note there. That more time since last maintenance, more time since last maintenance, more time since last maintenance, leads to longer installation time. Leads to longer installation time. More time since last maintenance. If you took, in this case here, a lot of time since the last maintenance today. So those things, of course, there will be so many things that have worn out. So more time since last maintenance leads to longer installation time. So you can see, ladies and gentlemen, installation time, and now this means that you see more time since last maintenance. So it is more and more. This is what we call in mathematics a direct relationship. So this is a direct relationship. You can write there. This is a direct relationship. Direct relationship. So direct relationships are also known as positive relationships. Positive relationships. Direct relationships are also known as what here? Positive relationships. Yeah. So more time since last maintenance leads to longer. So it's more and more, one-on-one. So one-on-one means what, ladies and gentlemen, here? That if you have this here increasing, the other one also, so we have a direct relationship, which is also known as what here? Somebody a positive relationship. So then we ask ourselves, do we have a positive gradient between this x1 and y? Is the gradient positive? Because see, we have a positive relationship, isn't it? So if the gradient is positive between x1 and y, automatically that shows what your plausibility. That shows plausibility. It makes sense. The relationship makes sense here. So tell us there that therefore, the relationship between x1 and y, is positive. No, makes sense, sorry. Makes sense since it is positive. We can see it is positive 0.38762. The relationship between months and installation time So it makes sense. And if it makes sense, we say straight away, it is what here? It is plausible. It is plausible like that. It is plausible like that. The relationship between x1 is months, remember, and y makes sense because of how it is, since it's positive. So positive that, it's plausible like that. Now go ahead and make arguments with type. Go ahead and make arguments with type. So we have, first of all, understand what is this type. Please read for us. What does this type stand for? Maintenance problem. Maintenance. What here to maintenance? What here somebody? Problem, yes. Maintenance problem. Can you kindly try to understand this in your own way? This maintenance problem in your own way. Try to understand it first. And then tell us what is your expectation. What is your expectation? So, of course, we appreciate the fact that the bigger the maintenance problem, the more the installation time will need. The bigger the maintenance. The bigger the maintenance problem, the more time, the more installation time, the more installation time needed. So you can see more and more. Meaning what here? Somebody a positive relationship or a direct relationship. So we expect, so in short here, we expect a positive gradient. A positive gradient. Then we go ahead and ask ourselves, is it actually positive? Is the B there positive? We are not together. Is it? Yeah, it is this B2, isn't it? Yeah, and in this case here, B2 is actually positive. And therefore, plausible. Makes sense. And therefore, plausible. That's how you check for plausibility. I'm so sure by the time I do the third question, all of us in this case here will be very comfortable. All of us will be very, very comfortable like that. So have you gotten some idea out of now this question? Have you gotten some idea? Yes. Yeah, if it is larger, if it's larger than its book value, the better, yes. The better. Great. So I hope at least you've been able to pick something out of that. So you can now allow me to go to the next model known as high-low method. Mentioned there, high-low method. Usiandike high ya kusalimiana. You know, there are three models in this, in your level here. This topic number 2, there are three methods. We have regression. Then number 2, we have high-low method. And then lastly, we have what we call learning curves. Learning curves. So now we are doing number 2. Very easy. You did it in management accounting, although we don't make assumptions. So right there, high-low method. High-low method. High-low method. So right there that this is a simple technique. This is a simple technique that is used to separate mixed costs. That is used to separate mixed costs into fixed into fixed cost and the variable cost components using highest and lowest X values. So it is quite a simple method that is used to separate or split what we call mixed costs into fixed cost and the variable cost components using the highest and lowest what here somebody X values. Illustration. So you are given X here versus Y. So you have in this case here 10, 12, 15, 18. We have 22, 24, 28, 32. And then you are told in this case here to develop a high-low equation. 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 All right. So the online students, are there students who have been able to understand what I've done? Anybody there who is able to understand what I've done completely? Let me get feedback online, guys. Online guys who have been able to understand and follow completely what I've been able to do. A little bit, okay. Yeah. So of course there are those who have floated. So then the very best itakuwa, you guys need to do what here to watch the video. You need to watch the video. Don't be cheated that umefloat. This was a homework question and so many students have been able to do it correctly. So many students have been able to do it correctly. Eka bidii. Hii ni subject ya bidii. Hii ni subject ya bidii. So many students have been able to do it correctly. It was a homework question. Yeah, it was a homework question. So watu ambao wanaandika wako nje, ignore homework. Ignore homework. International is because even if I stay here explaining this thing the whole day, if you're not doing your part, you'll not understand it. You'll not understand it. And if you do your part, like most students were able to give us answers even much earlier. Like when I was getting XAs up to XDs, the students were writing up to XD. Up to XD. It is not difficult. Yeah, it's just perception. So like now this one, high-low method, what we do? We select the highest X value point. Highest X value point. So we have here X versus Y. All right. So when you look at X values, which one is the very highest? 18. So you don't pick 18 alone. You pick it together with the Y coordinate. You take a point. So then here we have 18 versus what here, somebody? 32. And then, of course, it's high and low. So come and pick the lowest, not Y, but X value point. X value point. So Y, X value point, are you able to see it? The lowest X value, not Y. Lowest X value point, it is what here, somebody? 10. So you pick it 10 with 22 like that. So you write here 10 with 22 like that. And again, the other way of you knowing AMA is to participate. You give us answers. So long as you're talking to me all the time, you'll be able to pick this very, very easily. So now you've been able to select the two levels of activities needed. We have the lowest X value and the highest X value point. So 2 points only. You leave out the others. After you do that great work, you'll be able to go ahead and form two simultaneous equations, yes. You form two simultaneous equations, yes. Remember, they have to be of the form y equals a plus who? Bx, yes. So use the highest x value point, substitute here. You give me the first equation. Give me the first equation. So please try your best and give me the first equation. What do we have there? Try your very best. Give me the first equation. So it is y. 32, isn't it? Equals a that we do not know plus bx. So b times what here, somebody? 18, isn't it? Bx. Yeah, you can still call this equation 1. Get the second equation. Second equation, we have y, which is 22, equals, I'm substituting here, a plus b times who, somebody? 10. Equation number 2. So go ahead and now, of course, you can see what is happening there, ladies and gentlemen. We can't leave those things with times. We have to write these in a proper way. So proper way, it will be 32 equals a plus 18b, equation number 1. And then equation number 2 is 22 equals a plus 10b, isn't it? So then we eliminate a through subtraction, right? Eliminate a through subtraction. So 32 minus 22, that gives me what here, somebody? 10. A minus a disappears, isn't it? Which was our objective, to eliminate a. 18 minus 10 gives me what figure, somebody here? 8b. 8b, isn't it? Therefore, b will be 10 all over 8, like that. So 10 all over 8. Thank you so much. They're getting 1 point what here, somebody? 1.25, isn't it? Thank you so much. So then, having gotten the value of b, we can easily go to any of the 2 equations and get the value of a. So we ask ourselves, what will be the value of a from equation what here, somebody? 1. Please try that out. Try that out yourselves. So this will be 32 equals a plus 18, boy, but we know who our boy is. We know that our boy is 1 point what here? 5. So then can somebody do the abracadabra here and they give me? So this will be 18 times 1.25. Are you able to give me this figure? 22.5. Thank you so much. Then we make a the subject of the formula. So meaning that this has to cross over. Here it's positive, on the other side it becomes what here? Negative. So it will be 32 minus 22.5 equals a. Therefore, a will be equal to what here, somebody? 9.5. So when you write your equations, don't forget our y was a plus what? Bx. So then our y will be equal to a which is what here, somebody? Plus b, which is? Now let me ask you a question. In this equation, kind of an equation, you are asked to tell us what is fixed cost. Fixed cost will be equal to what? 1.25. Wrong. Si fixed cost kana kuanga hivi na nibu kumbuka vizuri. Cost equals Vx plus F. Kuna kumbuka. F inakuanga peke yake independent. So regardless of where it is, I can see that this 9.5 does not depend on F. So this automatically will become what your fixed cost. And then of course, variable cost per unit will be 1.25. I'll come back to that later. But for now, ladies and gentlemen, can you kindly do me a favor here? Let me give you this question you tried. Exercise 2. Now this is yours, class exercise. So we shall overcome. We are given here x, y, right? So we are given here 3, 8, 9, 7. We are given here 20, 23, 19. Yeah. 19, 18, something like that. Can you kindly now give me the high-low equation? Let's see. Give me the high-low equation. Abracadabra. Give me the high-low equation. Please participate. This subject needs you to be active. An active learner, not a passive learner. Inataka mtu anaongea, ataka unaongea uongo. Utapita. Utapita. Yes, Joanne, you can also use change in y over change in x. Yes. Perfect. Many ways of killing a rat. So high-low equation. High-low equation. Very good. Very good. I can see Knight and Harriet, what they are saying there. I can see Knight and Harriet and Ken as well. I can see what they are saying there. They are telling me something nice. They are telling me something very nice. They are telling me something very, very nice. So, ladies and gentlemen, kindly help me identify the highest X value point. You know, when we talk of the highest X value, we are very categorical. We are not looking at Y at all, isn't it? So then the highest X is what here, somebody? So you don't say 9 and 23. It is this 9 and what here, somebody? 19. So it is 9, and then we have 19 like that. And then now we have the lowest X. We are calling them X value point. So the very lowest is which one here, somebody? So you take the lowest X, which is 3, and they correspond, and the corresponding. So 3 and 20, isn't it? 3 and 20. Yeah, then you go ahead and form equations. So we have our equation being y equals a plus bx. Two simultaneous equations. We start with the highest. So the highest, what is the y? 19. Equals a, which I do not know, plus bx. So b times what here, somebody? 9. 9, isn't it? Yeah. And then y, second one, it is 20, isn't it? Equals a plus b times x. X, which is what now here? 3. So this is 1. This is 2. Go ahead and write them properly. Rewrite them properly. Rewrite them properly. So then this will be 19 equals a plus 9 boy. Right? 20 equals a plus 3 boy. 1, 2. Subtract. So 19 minus 20, that gives me minus what here? Yeah. So this disappears, right? This gives me what here, somebody? 6b. Therefore, b will be minus 1 over what here? 6. Which gave you guys minus 0.167. Yeah. And then now we can easily get a from equation 1. From equation 1. So it will be 19 equals a that we don't know plus 9b, which is negative here. So then this will be 19 equals a. Could you kindly give me this? 9 times that. 1.5 minus 1.5. So take this to the other side. It will be 19 plus 1.5 equals a, isn't it? Meaning that a equals who? 20.5. Have you been able to write the regression, the high-low equation? So this one, I would want you to look at your past papers as a classwork, not classwork, but homework. As homework, I would want you to look around your past papers and see whether you'll be able to identify a high-low equation. Question. a high-low equation question, I would want you to look for that kind of many times students will call me and then they tell me, Mwalimu, I don't understand this question is coming from which topic. So now this one I'm leaving it. There are many questions there. Which want you to form a high-low equation. But again, there is catch word. And your examiners always use this catch word to catch so many students. Your examiner will not tell you which one is X and which one is Y. Your examiner will come and give you something like this. He'll give you two variables. He'll give you two variables. Maintenance cost here. Maintenance cost. He will give you output. Yeah, from a machine. So blah, 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 blah. So between the two, ladies and gentlemen, which one will be Y? Maintenance costs. Yes. Because remember these questions, this topic is under what we call cost estimate. They want to be estimated always goes to the what? Which one do they want me to estimate? Is it maintenance cost? Yes, that goes to the Y. This one here goes to where? Somebody here? X. Now let me ask you a question. So if, for example, they give me this kind of a question, and then they tell me to come up with a regression, so I come up with a regression like this. Y equals 10 minus 2x. According to your understanding, this equation now here, will it be plausible? According to your understanding, your inner thoughts, the brighter you... Why are you saying no? Why are you saying no, you bright people? Talk to me. Give me a reason. Why are we saying no? We expect in this case here, these machines here to spoil more when we produce more. The more we produce, the more the production, the more these machines here will spoil, and therefore maintenance cost will be increased. So we expected a positive water relay, and then here they are giving us what? Negative. When they're giving us negative like this, it means that if the output is millions, that your maintenance cost is going, is that normal? That is abnormal. Otherwise, when in this case here, the output is the millions, then we expect also the maintenance cost always to be done doing what? To be increasing here. So we expected a direct relationship here because these ones, in this case here, are directly related. Now, let me ask you another question. What if I had two variables? Variables like this. This one here, I don't know whether they'll be able to get it right. This one, we can bet. This one, we can bet. We have here sales versus advertising cost. Will you tell me that always cost goes to the Y without reasoning? Which one do you think in this case here will go to the Y between the two? Which one depends on the other? Sales depends on how much we advertise. So the dependent will always go to the Y. This one here goes to where here somebody X. If you confuse the two and a high-low method, utashangaa umerogwa, unaanguka hizi exams through. Na hakuna kurogwa hii dunia. Hakuna kurogwa hii dunia. Do you understand vitu vizuri? Now, with your permission, ladies and gentlemen, I will be able to go to the last method called what here, number 3, the learning what here? Learning curves. Please mention there, learning curves. Learning curves. Assignment, thank you for asking. What have we said, Harriet? This one, I'm leaving it upon you. You produce through your, that's part of your assignment. Produce through your past papers, identify high-low questions. That's part of your assignment. I hope I'm clear on that. I hope I'm clear on that, Harriet. I hope I'm clear on that. Thank you so much. The other thing of you loving AMA is to ensure that whatever we do every day, you repeat immediately. Learning curves. Usingoje pile. Usingoje pile. Ukingoje pile itakuwa international disaster. But I normally take pride for the number of years I've taught this. I've taught this for 25 years. I doubt whether there is anybody who gets the pass rates I get. Even the students I had last semester who are online here, wakaanguka, unaweza ni blame. Hebu jibu hiyo swali. Kama ulikuwa na mimi pala semester ukaanguka, unaweza ni blame? Hebu sema ukweli kabisa bila kuogopa. Unaweza ukani blame kweli kama ulikuwa no blame at all, because I gave you all the 5 questions. It is only that now the examiner marked your papers maybe badly, or maybe you are very, very busy. There are those students who normally tell me that, Mwalimu, you know what? I'm a young mother with a 2-year-old, not 2 years, 2 months. Yeah, again, I know their work becomes what you're quite crazy. I did my best, yes. We shall overcome this April. Oh, 4 consecutive classes without break. Joanne, we shall overcome. And I normally tell you, ladies and gentlemen, also these papers here, don't do so many of them as if CASNEB is going anywhere. This thing just do 3. Yeah. Not unless you are doing a paper called Advanced Public Finance Management and Audit. I don't know, I can allow you to do many. But if you are doing the core papers, yeah, and then you do, and then it happens that you are working. You are working, you are married, you have children. No, hakuna haja haraka. Nyinyi mnafanya papers ngapi? 3, yeah. 5. 3, isn't it? So you're doing 4. Why are you doing 4 and not 3? Or you only have 4 before you go to BDA? Not 5. You know, there's supposed to be 5, or you passed the other one. Yeah. So there is a ninja here doing 6. Yeah. They're doing what we call double specialization. Those are good students who have been mentored very well. We have what we call double specialization. So under double specialization, they are doing AAA and plus advanced tax at the same time. They're not choosing one. This is what I normally tell all my students to do. This is what I normally tell all my students to do because of what here? The audit license. All of you, of course, at the end of the day, you would want to practice in the future. If you want to practice, you would want to practice. You will not be given an audit license if you do advanced tax alone. You can't be given an audit license. So if you are given a tax license alone, the question will be, will you be able to get clients outside here? I run an audit firm by the name of Aura Company, which is based at Westlands, Havenscott. And I can tell you, most of our clients in taxation, we get them because we are their auditors. All these KTDA factories that we are also representing at the tribunal at KRA, we basically got them because of the audit work we are doing for them. Because when you're auditing them, you go to realize, there is a tax issue. Once you explain to them very well, then they give you. But getting a job directly as a tax practitioner, it can become very, very hard. Again, you can't run a firm alone by just doing what you audit. Audit, you see, audit fees is really, really tiny. It's very hard for you to get anybody who will be able to give you like $1 million shillings for audit. Audit assignments, 300, 400,000, isn't it? Can they pay you 10 or 20 members of staff? No. The thing that has got money is representing clients who, for example, owe KRA like how much? We love these clients. 100 million. Those are the best clients. You represent like two or three, and then you are able to do wonders, like that. So you have to combine, you complement the two. But the good thing is, like now the sister is doing 4, and I'm so sure I can't convince her to do 5, right? So then CASNEB allows you to do what you have to finish CPA, and then you come back and do the other specialization. They allow you to do that. Yes. They allow you to do that. Is that okay? Yeah. My take on remarking, so many students of mine asked me about AMA students last semester. They told me AFR, I failed, because that paper for sure last semester AFR was crazy. That one they accepted. But AMA, they feel that Mwalimu, this paper was marked badly for us. So they are thinking that they go for remarking. You'll be wasting your 7,500. You'd rather call Mwalimu here like over the weekend, like tomorrow, before I come for my 6 p.m. class here. Tell me, Mwalimu, kuja tukule kanyama mahali hapo 75 hii. I can tell you, I can tell you 100%. Assume in this case here, for example, you are a CEO at CASNEP, and then there are so many guys who are coming for remarking. Even if they pass, will you be able to allow them to go through? Put yourself in the other side of the coin. You can't, isn't it? Because that will automatically show that there is problems. There are problems in the examiner. So don't waste your. I can tell you. I can't tell you the role I normally play, but I can give you an assurance. Bring that money, we eat it. Sasta mchana. Sasta mchana. Bengia class up, soba pita. Prove the examiner wrong. Sawa. So remarking no. Eh, Pamela Wabomba anasema mwalimu, unapitia mambo mengi sana. Mambo gani? Hii cast ni hatari eh? Oh, kuna proven naona wanasema kila mahali eh? Wanasema kila mahali. Yeah, so Sam is asking, no, first of all, there is a Olango Francis. What is the advantage of double specialization early if someone can come for it later? Yeah, you know, Olango, one thing we're forgetting is that we have students who are full-time students. These guys are not doing anything apart from doing this CPA. They're not even looking for food. Their parents are looking for food and everything. Those guys, don't you think they need to do like 6 papers? Yeah, they have the time. They have all the time, yes. The Gen Zs. Then Sam is asking us, how do we pass in this paper? Last semester, I had over 500 students who are doing AMA. And if I count very well, it must be over 450 who passed. I'll be doing my mathematics, yeah, over 450. Now, the students who are with me here last semester and they failed, what do you think in this case here, these 450 guys did? I gave you 4 mocks. Those 4 mocks, the guys who are here, they did all the 4 mocks and finished, and we revised together. They attended all the additional classes. Remember last semester we were doing how many AMA classes? 4. Even if you're starting with 3, itafika mahali hata si mimi nitawaambia nyinyi mtaniambia mwalimu ongeza session nyingine moja ya mtaniambia wenyewe. So itafika 4. And that's why I don't want to do 6 papers. Yeah, so they attended all sessions. Then the other thing, you shall never disregard theory questions. Theory areas, we must be very, very good. When we say balance scorecard, you must be remembering the perspectives. Because in this paper, 30% in this case here has to be what here, theory, yes. And then, of course, most importantly, the being what here, somebody active. Because I know, I mean, the students forget in this case here, at times and put their cameras on. Like I saw Pamela here, ulikuwa umeacha kamera yako on na ujue. So nakuta kama mwingine ameweka kamera on, nafunza AMA so seriously. Na jamaa ametoa shati omena na uga. That kind of a guy, will you pass in this paper? You can't pass this paper. You can't pass this. So very, very active, very active in class. Wachana mambo mengine yote. Hata kwa mfano kwa unasoma kwa na family, unaambia family sasa hii ni AMA. Wakati wa audit and assurance piga kelele na family hata watoto naambia kuja tucheze kidogo. But kama ni AMA, it's a serious paper. AMA is a serious paper. AMA is a serious paper. The power of men, right? I'm 100% sure. And really, that is now one of the downsides of studying online. I'm so sure even right now as I speak, there must be somebody anachapa omena na ugali. 100%. Saizi as we speak. Now probably hata afanye uko unakula chakula ambao unakula kwa kijiko At least unaweza kuwa unaandika kidogo namna hii. Lakini sasa chakula ambao unatumia honestly and this advanced management accounting. No, you're not serious. So I hope I've answered your question. And now we can go back to learning curves. It's 5:55. Where has time gone to? I wanted to finish this topic, but now unfortunately, you know me, I have the energy. I can go to 8:30. But these guys, I'll be putting them too much. Wachie hapo, right? Yeah, wachie hapo. Right. Thank you so much. Have a good night. Bye. I will do my classes from here. Here, yes, 6 p.m. Yeah. Is it 5 or 6? Tulisema 6 p.m. Kuna inaanza saa ngapi? Yes, Kuna AFM 5 to 6, but AMA wale wanafanya AFM unakuja 6 hapa. That's what we agreed. Thank you so much. Bye. All right. Wanafunzi wa online